Imply Polaris is a cloud-native database as a service that simplifies the developer experience by providing all of the advantages of Druid, plus a slew of other benefits such as auto-scaling, push-based ingestion, enhanced security, and interactive visualizations with sub-second query response. Imply Polaris delivers everything you need to start your analytics projects fast. In this demo, we're going to pretend that you are the plant manager at a chip manufacturing company. I'm going to show you first how easy it is to ingest the data, next how fast it is to query the data, and lastly how efficient it is to explore the data from multiple dimensions with real-time visualization. When you first open the homepage, you'll see intuitive navigation on the left-hand side of the screen. The options are broken down by data, analytics, and monitoring. Ingesting data into Polaris is very easy. We'll click on Sources and then navigate to Create Source. And you'll see you have a number of options from streaming and batch, from Amazon Kinesis, Confluent Cloud, Kafka, Amazon S3, Azure, and more. In this case, we're going to look at a Confluent Cloud example. Here, the dialog box will ask you to specify the connection name, the topic name from which you're ingesting, Bootstrap server's API key, and so forth. And you'll create that connection. I actually already have demo data loaded, so I'm going to X out for now. What happens from here is that the data is ingested and Polaris creates a table. So we'll click Tables. And for this demo, we'll be using Imply IoT. This table has about 1 billion rows, so it's a fairly substantial number of rows on a relatively small cluster. And the first thing that happens when you set up a connection is that Polaris starts to sample the data, break it down, and make some assumptions. Let's look at what those assumptions might be by just looking at a create table option, which I skipped earlier. When you're ingesting, Polaris creates the data model, which is rolled up on ingestion and automatically indexed. You can view the detailed table, which is the raw data, or you can configure a roll-up on ingestion in order to manage the size of the cluster and help improve the query speed and query latency as it ingests. You might want to start with a strict table schema, which is kind of a default if you want to actually define each data field in advance as you go through. But that's a lot of manual work. And one of the main advantages of Polaris is the ability to choose a flexible schema for elegant schema evolution. In this case, as new columns are added, Polaris will automatically update and index them, which saves a lot of time and manual effort as data formats evolve going forward. So let's go back to our table. Again, in this case, we have flexible schema auto detection. So it's automatically detecting these as a timestamp, string, long, and so forth. And we have, again, over 1 billion rows here. And Polaris is doing a lot of the heavy lifting automatically to streamline the process. There's also a lot of APIs for these ingestions, and as an API-first company, our goal is to save you a ton of time in automating. So we've now showed you the first point, which is how easy it is to ingest the data. Once you've built your table, you or your end users can easily visualize the data. Our UI is designed to be self-service, so let's go into one of the dashboards as an example. First, let's look at the kind of query speed that we're talking about. If you click on the filter options icon, you can see that we've set up the refresh rate to 5 seconds. And if we monitor those queries behind the scenes, you can see that it's in the hundreds of milliseconds per query. There's hundreds, if not more, of these queries happening all the time. You can see the query itself and where the query spent its time. And really, for any triaging or optimizations you want, this is the kind of insight that you need instantly to see where those bottlenecks are. So you've now understood that second point. In order to get sub-second queries, no matter how much the data, how many concurrent users, or how many connected devices, you're still going to get that sub-second performance. So now let's move on to our last point, which is really about the ease of visualizing the data. And in this case, all the tiles in the dashboard are designed to help users understand defects throughout the semiconductor manufacturing process. There's a lot of filters that you can use in order to get instant insights. But in this case, let's look at what's actually happening over the past week, given that we're just looking at the latest hour right now. Immediately, we can see there's something happening on Friday specifically, right? And if we hover over this specific area, we can then filter and see that plant 4 is causing some sort of anomaly in terms of defect ratios. So let's click this tile to expand it and understand why that might be happening. So this is one of many graph visualizations that we have here. It's a line chart by default. You can see there's over 16 different options in terms of stack, tree map, geomarks, etc. that you can choose from. But just to keep things simple, let's choose table to further identify what's going on here. So as you can see, there's a lot of different dimensions and measures that you can choose from in order to customize this table. So first, let's actually just eliminate time as a filter because we've already identified September 20th, 3 a.m. to 1 p.m. as the time range. We don't really need to see the per hour variance, right? That's not super interesting to us. So when we look at dimensions, let's start by adding machine ID. And immediately we can see that machine 44 and 40 are having a way higher defect ratio than other machines. Just to understand kind of how defect ratio compares to other types of measures, let's go ahead and add yield. This isn't necessarily giving us new information, but it does allow us to look at it from another vantage point. In this case, yield is the percentage of accurate machines, right? So it's the inverse of the defect ratio. 100% minus 10% is about 90%. But if we want to understand kind of why that's happening, we need to add some more dimensions. So let's go ahead and add machine provider. And here we can see that the advanced XF machine is clearly having a much higher defect ratio than any of the other machine types. So let's actually take that machine provider type, advanced XF, and add that as a filter to dive deeper. So what else can we add here to kind of pinpoint what might be going on? Maybe it's the material that's used, right? All right, we see silicon multi-layers clearly having an issue compared to some of the other types. Why might that be? Maybe we can look at the material provider. All right, not super interesting, right? We're seeing that they're all from Next Materials, which doesn't give us any new information. So let's go ahead and X that out. And just to make it a little easier to see, we're going to add silicon multi-layers as a filter. And let's think about, what else can we add to understand what might be happening? Maybe it's actually the machine configuration. Okay, actually, that's interesting, right? Because in this case, plant 4 is having only the vendor default setup at about a 17% defect ratio, whereas plant 0 also has silicon multi-layers, but they're only seeing a 2% defect rate, right? So that's probably what's going on, and we probably need to look at the actual machine configuration in order to figure that out. And you can see that actually in a few minutes, we were able to quickly identify what was happening, and every time I clicked, we saw a sub-second response. So let's go ahead and go back to the dashboard because we've shown you now the third point, which is how you visualize and explore data from multiple dimensions. You can drill down into the granular data because it combines the event data with all of the dimensions and the metadata. Users can quickly triage issues and get to root cause analysis. And overall, we've showed how easy it is to ingest data using capabilities such as schema auto discovery and automatic indexing. You've seen the system's high performance, delivering answers with sub-second queries on aggregated and rolled up data, while still providing access to granular events. And lastly, we've shown you how to visualize and explore the data to gain insights using Pivot, which is available for immediate use or can be white labeled if you'd like to create similar dashboards with your brand name for your external customers. Thank you so much, and please feel free to reach out if you have any questions.